Good day, students. This is topic 2, lesson 4, equations of parallel and perpendicular lines. So we've had a lot of discussion about parallel and perpendicular lines and the theorems that go with these two different types of lines and how we use these theorems to solve problems given um, parallel lines and transversals or different types of figures that involve perpendicular bisectors. But today we're going to look at parallel and perpendicular lines in a different setting, and that is on the coordinate plane. And we're going to look at equations of these lines and what they actually entail. So let's get okay, so we are in example 1, writing equations of parallel lines. It states what is an equation of the line that passes through the point 9, negative 6, and is parallel to the line y equals negative 3x plus 4. So we all know from our warm-up activity that parallel lines have equal slopes. So the slope of the required line has to be the same slope as the line that's given. So as we can see, the line that's given to us, y equals negative 3x plus 4, is in slope-intercept form, which is y equals mx plus b, where m is our slope. So we can see here our m is negative 3. Well, that's kind of dark. Let me lighten that up. Negative 3 is our slope. So that tells us that the slope of the line that we're going to create has to also be negative 3. Now, because we have our slope of negative 3, we also have our line, our point for the new line that's passing through, which is going to be 9, negative 6. So we have a point, we have a slope, so of course we're going to use the point slope form, which is y minus y1 equals m times the quantity of x minus x1. So now we're going to substitute our slope and our point into the equation. So we have our y1, so let's first label here, we have x1 and y1. Our y1 is negative 6, our slope is negative 3, and our x1 is 9. So if we want to stay consistent and identifying what everything is, let's keep everything highlighted so we can know where everything is in our equation. So now we're just going to clean up some things that we see so that way we can simplify our equation and turn it into our slope-intercept form for the equation that's parallel to the original. So we have y minus a negative 6. We know negative and negative gives us a positive. And then we're going to take this negative 3 and then distribute it to everything inside the parentheses. So when we simplify, we have y plus 6 equals negative 3 times x gives me a negative 3x. And negative 3 times a negative 9, we know a negative and a negative gives me a positive. So that's going to be a positive 27. Once again, we're solving for y because remember we want our equation to be in slope-intercept form. So that means that we're going to be subtracting 6 from both sides. So that leaves us with y equals negative 3 plus 21. So the equation of the line that's passing through the point 9, negative 6 is going to be y equals negative 3x plus 21. And you can see for sure that this is our equation because in fact the slope is the same as the original, which is negative 3. So we're going to do one more equation or one more example of writing parallel lines, writing equations of parallel lines. Example 2 says, what's an equation of the line that passes through the point 7, 3? So let's go ahead and highlight that. And is parallel to the line y equals negative 2x plus 5. So once again, we're looking for a line that's parallel to it. So we know that it has to have equal slopes. Remember, parallel means equal slopes. So we see here that the equation that's been given to us is in fact in slope-intercept form. Remember, that's in the y equals mx plus b form. And we know that because it's in this form, that our slope is going to be m. So the slope that we're needing is negative 2. So the slope that we're going to be using is negative 2. So we have our point, x1, y1, which is 7, 3. We have our slope, which is negative 2. So now that we have our point and our slope, we're going to use our point slope form. And we're going to take our slope and our 2 points, or our x 1 and our y1 and plug it in. So we have y minus y1, which is 3. And we have our slope, which is negative 2. And our x1, which is 7. So let's go ahead and highlight everything so we know where everything is. That was our slope. And these were our 2 points. Okay, so now that I have everything, we're just going to go ahead and distribute our negative 2 to everything inside of our parentheses and simplify. Y minus 3 equals negative 2 times x gives us a negative 2. Negative 2 times a negative 7 gives us a positive 14. And then we're going to add 3 to both sides to solve for y. And I get y equals negative 2x plus 17. And we see that this is the equation of the line that is going to be parallel to the original line that was given because we have, in fact, our slopes as being the same. All right, so let's go ahead and change gears and look at writing equations of perpendicular lines. Example 3 says, what is an equation of the line that passes through the point negative 6, negative 8, and is perpendicular to the line y equals negative 2/5 x plus 12? Well, from our warm-up activity, we remember that the product of the slopes of perpendicular lines is negative 1. So that means if I add multiply the two slopes together, the result should be negative 1. We also remember that perpendicular lines have opposite reciprocal slopes. Okay, so that means the slope of the required line should be what? Well, let's go back here and look at our original line that was given to us. We see that the line given was y equals negative 2/5 x plus 12. And here we have a slope of negative 2/5. Well, we know that perpendicular lines have opposite reciprocals. So that means that the slope of the required line has to be the opposite reciprocal of negative 2/5. And the product, when I multiply these two slopes together, has to be negative 1. So I know the opposite reciprocal of negative 2/5 would be a positive, and if I flip them, 5/2. And we just want to make sure that when we multiply these two together, we actually get negative 1. So negative 2 times 5 gives me a negative 10. 5 times 2 gives me 10. Negative 10 divided by 10 gives me 1. So I know for sure that my slope of the required line has to be positive 5/2. So I have a point. I have a slope, and then I have a given point here of negative 6, negative 8. And because I have a point and a slope, we're going to use our point-slope form. And here we're going to substitute in our slope, our x1 and our y1. So y1 is negative 8. Our slope is positive 5/2. And our x1 is negative 6. So before we solve for y, we need to simplify some things in our equation. So we have a negative and a negative here, y minus negative 8, that turns into a positive. And we're going to go ahead and distribute our 5/2 to everything inside of the parentheses. So that brings it down to y plus 8, and then we have 5/2 times x, which gives me 5/2 x. And then we have a negative and a negative here, so that becomes positive. And then remember, we have to distribute, so 5/2 times 6. So let's go over here and do some multiplying here. We have 5/2 times 6, which really is saying, 5/2 times 6 over 1. And then when we are multiplying fractions, we multiply straight across. So we have 5 times 6, which is 30. 2 times 1, which is 2. 30 divided by 2 is 15. So we have 5/2 times positive 6, which gives us 15. And then once again, we're solving for y because we want this in slope-intercept form. So I'm going to subtract 8 from both sides. So that leaves me with y equals 5/2 x plus 7. So the equation of the line that's parallel to y equals negative 2/5 x plus 12 and goes through the point negative 6, negative 8 is y equals 5/2 x plus 7. And I know this to be true because I see here that my slope of 5/2 is the opposite reciprocal of the given slope of negative 2/5. All right, so let's take a look at this last equation example for perpendicular lines. So it says here, what is an equation of a line which passes through point 6 comma 9, and is perpendicular to the line whose equation is 4x minus 5y equal 15. So I see here it says perpendicular, and once again, perpendicular means we have the opposite reciprocal. So that means that the product has to equal -1. The product of both of the slopes of the two lines that are perpendicular has to equal -1. So let's look at the equation that's given to us. We have 4x minus 5y equals 15. Well, I see here that it is not in slope-intercept form. This is actually in standard form. So it's going to be a little bit difficult for me to find. It's not difficult, but we can rearrange this equation to find the slope a lot easier. We can rearrange it into slope-intercept form, which is the y equals mx plus b. And to do that, we need to solve for y. So they gave us the 4x minus 5y equals 15, and we're going to solve for y. So that means I'm subtracting my 4x from both sides. So that means I'm left with -5y equals -4x plus 15. I divide everything by -5. So that means I have y equals a positive 4/5 x minus 3. So now that I have this equation now in slope-intercept form, it makes it a little bit easier for me to identify what the slope is. So I see the slope is 4/5, right? But remember, the slope that I'm looking for has to be the opposite reciprocal, or the product of -1 when I multiply the two slopes. So I know the opposite reciprocal of 4/5 is -5/4. But I want to make sure that when I multiply it together, I actually get -1. So 4 times -5 gives me -20. 4 times 5 gives me 20. That gives me a -1. So I know for sure, in fact, the slope that I'm needing to use is -5/4. So we have our slope of -5/4. We have our point of 6 comma 9. And that's our x1, y1. So that means, since I have a point and a slope, I'm going to use the point-slope form. And I'm just going to take the information like we have been doing and plug it into my formula. So y minus y1, which is 9, equals m, which is -5/4, times the quantity of x minus x1, which is 6. So as we've been doing, we're going to simplify. So that means I have to distribute on my right. So I have y minus 9 equals -5/4 x. And then a negative makes it positive. And then I have 5/4 times 6. So let's do this on the side. 5/4 times 6/1, which gives me 30/4. Well, can I simplify 30/4? Well, yes, I can. If I divide the top and bottom by 2, which is the greatest factor that can go into both, that gives me 15/2. So that means I have 15/2 here. And now remember, we're trying to solve for y, so that means I'm going to add 9 to both sides. So I have y equals -5/4 x plus, and let's do this on the side as well, 15/2 plus 9. So 15/2 plus 9, and that's really 9/1. Well, I see the denominators are not the same, so that means that I can't add these as they are. So I have to change the denominator of one of these or both of these in order for me to be able to add them, and the denominators have to be the same. So I have a 2 over here already. So this 9/1 I can change by multiplying the top and bottom by 2, and that makes the two fractions have the same denominator. So I have 15/2 plus 18/2, and that gives me 33/2. So that tells me here I have 33/2. So now that I have my equation, I know that y equals -5/4 x plus 33/2 is in fact the line that's perpendicular to the original equation 4x minus 5y equals 15, because we have here the slope as being the opposite reciprocal of the slope originally had, which forfeits, and the product of both of those slopes is in fact -1. Well, ladies and gentlemen, that concludes our lesson for today. As always, please make sure that you're reviewing your warm-up activity in your OneNote class folder for all your vocabulary terms. And remember, the videos are there as well for you to watch. I will see you in class, guys. Have a great day.